people were increasingly trying to improve buildings and insulate them more, and sort of capture solar gain and things like that. And yet the buildings weren't actually reducing their energy consumption very much. And I know, I've come to know him quite well over the last 15 years, really. And I know he's very tenacious, very obstinate. And he, as he says in this quote, it offended him. He wanted to find out why. And as a result, a group, Wolfgang and colleagues, developed this row of experimental houses just outside Frankfurt in a small town called Darmstadt. They got some local state funding to do this experimental work, and it was very experimental. It was based on very good building physics and on a scientific understanding of comfort, and we'll be talking about comfort a lot more during this session. But it was experimental in the sense that if we build a passive house now, we've got a supply chain, we've got the products we need, then they had nothing that they needed. So they had to develop their own window ranges, their own ventilation systems. So extraordinarily experimental. What they found is that what they did worked. It's still working. It's been monitored extensively. There are 4 units here, and Wolfgang and his wife Witte live in one of them. They recently did quite an extensive monitoring of the building and checking the wall structure and things like that to see if it was all working correctly and was still sound and everything was as they expected. So this was a success story, and out of this has grown the development of the passive house standard and methodology that we know today. Now, that story about things not performing as expected that started Wolfgang off with this whole sort of journey, if you like, is one that's repeated here in the UK. This is a piece of work done by Leeds Beckett University, which is quite near to me. I live in West Yorkshire. And the Centre for the Built Environment there have done a lot of work monitoring low energy buildings. And what they do, they actually do what's called a co-heating test, where they physically test the building. They heat it up and check its thermal transmission. And what they found is, as you'll see here, each property, there is a blue column, which is what the predicted energy performance of the building was when it was modelled. And then the actual energy performance is the red column. And you can see there is a gap, and that gap is called the performance gap. It's very well recognised in the UK construction industry. And please remember that these buildings were buildings that were actually intended to be more energy efficient than the current building regulations. So typically 2/3 worse than expected. Now, you may not be surprised to know, given that I'm presenting this, that the passive house dwellings were here. And of course, there is very little performance gap. And this is what basically Wolfgang worked on, what the passive house standard is all about, eliminating the performance gap, getting very low energy buildings. So what is it? Well, it's basically an energy efficient building, a building that requires very little heat to maintain comfort within the building. And most of that heat will come from our own bodies, our household appliances, heat from the ventilation air that we recover, and some from the sun, not too much, otherwise we overheat. And there is a technical definition of the sort of threshold of the amount of heat, but to put it simply, that's a very small amount of heat. We do need heat in a passive house. It's not a zero energy building. That becomes disproportionately expensive to do. This is a sweet point where it requires a very small amount of energy, and it's a very cost-effective thing to do. But it's also about comfort, because when Wolfgang's colleagues were looking at the science, the building physics, they were also looking at all the research that has been done on how we make buildings comfortable. And the key feature of passive houses is that they're also very comfortable and very healthy. And I'm going to talk a bit more about that in a moment. There is a lot of science behind this, but you don't really need to know a lot of the science in order to be involved with passive house or even to be building passive house. We have a methodology that's supplied to us. We do need a certain understanding of building physics if we're actually a building professional, but there is a lot more behind this. The Passive House Institute is a scientific institute that supports this worldwide. So what have we got to do in principle? Well, it's kind of very simple. It's about very good building. It's about just building well, but also obviously we want to insulate, because we're not going to save energy and we're not going to make ourselves comfortable if we don't insulate. So high levels of insulation are obvious, but in with that, if we don't do other measures, then the insulation has of little effect. So we need to get rid of our thermal bridges. That means we need to particularly get rid of places where insulation thins down, or there's a reduction in insulation level, or where something goes through the insulation. And as we increase our insulation levels, those thermal bridges become proportionally much more significant. So we need to get rid of them, or if we can't get rid of them, we need to model them properly. If we're building insulated, we also need to build airtight. The two things go together. If we imagine wearing a well-insulated jumper and you go out in the wind, it has very little effect. You need air tightness in conjunction with insulation, which is something that seems to be relatively poorly understood generally. We need our windows, which can be the weak point of the building, to be high performance. So in this climate zone, we'll need triple glazed windows. And then we need an effective ventilation system. And that would be mechanical ventilation with heat recovery. And I should be coming back to all of these more. So this is just an overview. Now, what do you get if you build a Passivhaus standard? What's the advantage for you of building to this standard if you decide to do it? So you get comfort, you get a healthy indoor environment, and you get energy efficiency, and of course lower bills. And we'll just unpick each of those and have a look a little bit more at what we mean and what the outcome is. So starting with comfort. Now, comfort, most people will say, well, my house is quite comfortable. I heat it in winter. It's, what do you mean here? What does this comfort mean? Well, let's have a look at that. So let's start and look at the sources of discomfort to start with in conventional buildings. So the first thing we have in conventional buildings, including buildings built to the current building regulations, we have a lot of infiltration, a lot of drafts coming through the walls. Basically, we don't build very airtight, even in our new buildings, and of course our existing buildings are even worse. But a lot of air moving through the fabric of the building. We'll generally have cold surfaces on our old buildings. Obviously, many of our walls are cold. Even in new buildings, our windows are likely to be fairly cold. They'll only be double glazed. So we've got cold surfaces radiating cold radiance in effect towards us. And that affects our sense of comfort. If we've got cold surfaces, we will get cold downdrafts from that surface. The cold air will fall down, it will tend to cause a draft, and many of us will experience that as cold air moving around our feet. That increases our level of discomfort generally. Our feet are very sensitive to cold air movement. And finally, we'll get ventilation drafts. So we're either ventilating in old buildings, probably just by allowing the air to move through the walls. In newer buildings, we put in trickle vents, holes in the windows to allow ventilation, and some extract fans in the kitchen and bathroom. That allows cold air to travel, and that cold air will be affecting you even if you're not aware of it. So what do we do to then say, well, I'm comfortable? We increase the air temperature, and that will compensate. It does give us a level of comfort. It counteracts the discomfort of the fabric of the building, and that's what we mean, most of us, when we say my house is fairly comfortable. But of course, the cost of that is much higher energy bills and much higher CO2 emissions. The other things in terms of discomfort, slightly on the side, are that many newer buildings will overheat in summer and they'll be very uncomfortable. It's kind of an increasing phenomenon. And most modern buildings have quite poor indoor air quality. Older buildings, it tends to be better because they're so leaky that the air is moving through the fabric all the time. So what do we do about that? How do we increase the comfort of the fabric of the building? Well, the first thing is get rid of all those drafts. So make the building really airtight. And there is some science behind this in terms of the level of airtightness, so that we don't experience any air movement through the fabric of the building and experience discomfort. Make sure that surfaces are warm. That means insulating properly to high levels all the way around, with no bridges, no bits where the insulation is broken. We've got a cold bit. Make sure our windows are warm on the inside. So that means triple glazing in order to achieve a sufficiently high internal temperature. And then get rid of those ventilation drafts by pre-warming the air that comes in, which is what our mechanical ventilation with heat recovery does. That way we can then reduce our indoor air temperature and be comfortable, because the fabric of the building is actually inherently comfortable. In a passive house, we can also deal with the overheating, because we've got quite a good way of modeling the overheating as part of our methodology. And we end up with excellent indoor air quality, which I'm going to talk about in a moment. So we'll come to that. So healthy indoor environment. This is the other thing you get. Now, if you talk to people who live in passive houses, they won't usually talk first about their energy bills. What they talk about is the comfort and the feeling of health, the feeling of a fresher indoor air quality. Very nice air quality, feeling very comfortable, no mold. They often talk about the quietness of living in a passive house, because it's very, if air leakage can get into a building, the sound can get through the same gaps in effect. So an airtight building, we've been more acoustically insulated. Our windows are triple glazed, which improves that. We'll have no mold growth, because that's part of the methodology, showing that there is no mold growth. We get very good indoor air quality, because our air is filtered, it's coming in. So we filter out pollens and particulates. And we'll have no summer overheating, or very limited summer overheating. So that generally it's comfortable and healthy at all times. And as I say, this is what residents tend to talk about. In terms of air quality, this is a complex subject, and there are many, many factors that lead to poor air quality, from volatile organic compounds from our furniture and carpets and paints, combustion products if we've got gas cooking or anything like that, mold growth, dust mites, etc., etc. And all of those things need to be dealt with. They are dealt with in the building regulations in terms of ventilation levels, but it's not really very effective. Having very good ventilation deals with a lot of this. So with Passive House, we're optimally ventilating. Our mechanical ventilation is calculated carefully to give us optimal ventilation. What that also gives us is optimal humidity. And this is very important to our health, because if our building is well, generally most buildings in the UK are not too dry, they are too moist. And my own house, which is an improved Victorian terrace house, in winter we're often at sort of about 65% relative humidity, which is not terribly healthy. It begins to get towards a situation where we'll get more bacterial growth, we'll get development of dust mites, they're more likely to develop. There are a number of factors that mean that we're less healthy. The optimal humidity is in this band shown here, about 40 to 60%. And my own experience and experience of most people is that in the UK with MVHR, we're typically running between 40 and 50%. So absolutely in that optimal band for humidity. And this is key. It's key in terms of mold growth, although we wouldn't expect mold growth in a passive house because every surface is warm. There's no way for the moisture to condense. And of course, we get energy efficiency as well. This is a thermographic image, and it's actually the house in the middle that we're looking at, which was the first passive house retrofit in the country, in fact, in a street in Hereford. But you can see the difference. So the passive house retrofit, which is basic to the passive house standard, there is very little heat getting out, and therefore the walls are cold and showing blue, whereas the houses adjacent, there's a lot of heat leakage, and of course they're showing much warmer colours. So you can see the effect of you building to this standard. And you do get much lower bills. And this is some work done by the Passive House Trust last year, and it just compared the average new build. This is looking at regulated energy, which is all of the energy that's accounted for in our current building regulations in the UK. And with a new build, in theory, the Passive House was 55% less energy use for hot water, space heating, lighting, electricity. Those are the regulated energy elements. However, if you remember the performance gap, theory and practice are not the same. And the reality, if you account for the performance gap with new build, is that we're around about 73, 75% lower in terms of our regulated energy use. So a massive saving. And people will, residents of passive houses will talk about their very, very low energy bills. So what do we have to do? What actually does this look like? And I'm going to start from the beginning. So I could start with the insulation, but actually I'm going to start with orientation and then form, because we need to start at the beginning of the process. And the first thing when we're planning our building is just thinking about the orientation and being aware that a south-facing orientation is likely to be more efficient than a north-facing orientation, because obviously we're gaining some of that free energy from the sun. We don't want too much, otherwise we overheat. So that's something we calculate in our methodology. but it's important to be aware of, and it highlights that we need to start this process from the very beginning, from the where we first conceive of our building, not bolt it on later. The same with the form factor. This is something that people find quite difficult to get their heads around at times, but a simple form, a simple with no bits sticking out, if you like, or cross shapes or L shapes, will have the least surface area in relation to the volume and floor area of the building. That's called the form factor. If we make a larger surface area, we're going to need more insulation for the same amount of heat loss. So we need to keep simple form. We need to avoid complex forms. And again, this comes right at the beginning of the process. We can be thinking about this. It doesn't restrict our architecture. It just means that we need good architects thinking about very good design. We don't worry about having to have roofs to keep the rain out. It's just a fact of life. It's just the same thing. This is just simple numbers. Now, coming to the things that are seem more obvious, lots of insulation, of course. Typically in the UK, we might be looking at walls with, if we're talking about fibrous insulation, with about 300 millimeters, depending where we are in the country. Less if we're looking at polyurethane installations or something like that. The Passivhaus standard doesn't tell us how to build. You can build timber frame, cavity wall, ICF, whatever. It's neutral to materials. That doesn't mean to say that materials don't matter, but they're not included in the standard. As I said, thermal bridges are very important. We need to either eliminate them or model them. And we have to actually model them in computer software if we think we've got thermal bridges anywhere. We have to deal with air tightness, and we'll typically be using specialist air tightness tapes to do this. And while this might seem very onerous at first look, and if you're not used to this, it becomes second nature to builders once they get used to it. Our own team and my own company, they can't not do this. They just do it automatically now. And a lot of the detailing, if you get the detailing right, it's actually quite straightforward. And this is an example of what we mean by the air tightness. If we summed up all the leakage in a UK building regulations compliant building, it would be the equivalent of a hole in the wall about this size, about 440 millimeters square. And in a Passivhaus, it would be this sort of size, about 44 millimeters square, very roughly. And if we compare what that actually looks like, it's the difference between a hole in the wall machine and a credit card, which perhaps makes the point quite well. We're looking at very high levels of air tightness, one of the challenges. But again, once you become used to building like this, it isn't that difficult. And if we look at our leaky old houses that many of us live in, we've probably got the equivalent of at least 2 hole-in-the-wall machines leaking through the walls at all times. And then we've got the MVHR system. People are quite nervous about this. They think it's something very difficult. It's actually a very simple thing in many ways, much simpler technically than a gas boiler. But what it's doing is recovering heat, the outgoing heat, and of course delivering the ventilation exactly as we want it to be, rather than a very hit and miss approach with triple vents and extract fans that don't really work very well. This gives us optimal ventilation, and it's why so many people talk about the air quality in Passivhaus as being so good. We do need triple glazed windows, and there are plenty of now on offer. We also need to detail them well, and Paul Smith's presentation later, he'll be looking at this in more detail. We need to ensure that the thermal bridge of the installation, how the window is installed in the installation, is well detailed. And then the other plank of this is the accurate methodology. We've got to know that we've got to know what we're building, and this is what Passivhaus planning package gives us. Now, we don't have this with our UK methodology. Our standard assessment procedure doesn't give us an accurate prediction of the performance of the building. What it does is tells us whether the building will comply with building regulations, which is not the same thing. So Passivhaus planning package tells us how your building will perform. And then finally, quality assurance. If we buy anything really, we expect it to be quality assured. And yet, strangely, when we build new houses, we don't expect any high level of quality assurance. There's no real quality mark. We have a basic check with building regulations, but building control, but it's very modest. And fundamentally, there isn't really a quality assurance system. Passivhaus says you've got to build well. You've got to build what you've designed, and we're going to check it. So there's a real value in certification at all levels. So how much does it cost? The question that always comes up. Well, the answer to that is a little bit, you know, how long's a piece of string, if you like, it can be 25% more. It's been known to be, it can be down to a few percent more. And the key here, as I've started to say in this presentation, is that a lot of the costs that people do incur are because they don't start with Passivhaus at the beginning. They build in problems that they then got to sort out, and it's very expensive. So they build in a complex form that's difficult to work around. They build in details that are very difficult to make airtight. Then there's a lot of cost in that. But if we eliminate all of that, if we've got an experienced team doing this, then all of that should be eliminated. Then there are some quite modest costs. We need triple glazed windows. We need an MVHR system. We need a bit of extra insulation, a bit of extra air tightness. And those costs typically, work done last year by the Passivhaus Trust, showed that typically that could be at around 8% for best practice. And in the future, as Passivhaus becomes more dominant in the market, it's probably going to drop to around 4%. So I think if you're asking that question, if you use an experienced team, design and construction team, certainly you could expect 5 to 10% at the moment, might be a reasonable guess. If you don't start at the beginning, if you don't optimize what you're doing, it could be a lot more. And please remember that standards are going to increase this decade. There's no doubt. The projection is for the future home standard in 2025. Nobody knows what it's going to be, but basically the government has said it's going to 75 to 80% less CO2 emissions, which is around about Passivhaus. So cost of a new build by 2025 or thereabouts is going to have gone up significantly, and a Passivhaus is going to be very similar. So we might right now be building quite low standards, but certainly they're bound to improve if the government is going to meet its legal targets for climate change. We don't know what's happening in 2020. It was out to consultation that we're waiting for the government to tell us, but we think it won't be particularly good. And projecting further on, standards are only likely to tighten further. So, Passivhaus, where is Passivhaus in the UK today? Well, the first certified units were built in 2009. Two of them over in West Wales. But by 2010, there were quite a few pioneering projects on the ground and completed. And 2010 was when we set up the trust, as we could see that Passivhaus was beginning to get some traction in the UK and some interest. We set the trust up really to support and promote Passivhaus, as we felt it was very important as a sort of guiding light to the industry, if you like. And jumping forward, we've now got, I've just got a few pictures up just to give examples of the sort of range of types of, we've got many private houses built to the standard now. We've got quite a lot of social housing built to the standard, and these slides are 3 years old now, I think. There's a lot of, these are just a few examples, but it gives us sort of the types of things we're looking at. This was a list of pulled out last year of social housing projects either on the go or completed. So quite a lot of social housing built to the standard, and schools and offices built to the standard. Again, a few examples here. Quite a few schools now built to the standard with enormous benefits for the school children. Actually, we've got retrofit, some deep retrofit done to the standard, and we've also got some large-scale projects now in the UK, including the project I mentioned at the beginning, the Goldsmith Street, 105 new Passivhaus homes. Norwich has been doing quite a lot of Passivhaus and is committed to doing more. Camden Council are doing a lot. They've got 250 homes at the moment, and they've got another sort of about 500 proposed. And interestingly, Exeter City Council have done a lot. They will only build Passivhaus for anything they develop. All of their new housing is Passivhaus. And this new leisure centre and transport interchange is being built. This is groundbreaking, really. This is currently under construction and it's being built to the Passivhaus standard. So there is a lot of interest. However, we've got to say that it's a tiny part of the construction market at the moment. But I think its importance is it acts as a beacon. It shows what you can do, and it shows where we'll need to go in the future, and pretty near future in reality. This is a graph from last year from the Trust, the number of certified units and the number under development. That number has gone up significantly now, and I should update this slide really. And just to give you a few other examples of Passivhaus, just so you're not restricted in style, this doesn't limit what your dream home could be. This is Passivhaus in the Outer Hebrides. These are all award-winning projects. It's a very simple home, family home in Herefordshire. This is, this is vernacular in Norfolk, social housing. You would not really be able to tell that was a passive house unless you knew. And a more modernist building in the Scottish borders. It's the borders, it's in Scotland anyway, by Gaia Architects. So it just gives you an idea of you're not limited. You don't need to limit your imagination for your dream home, if you like. So what are your next steps? Well, let's start with some questions, really. I get approached a lot, and a lot of us do, about, well, we kind of want to take some of these lessons, but we want to use the principles, but we don't want to go all the way. So my question is always, what would you leave out in all of this? So would you leave out the accurate modelling, which is absolutely the core of this? And without it, you are spending money without having any idea what the effect is going to be. And that seems like a lot of wasted effort to me. You certainly could leave out the quality assurance and certification, and you might, if you've got an experienced team throughout who you know can do this, that's fine. But if you don't, how do you know you'll get what you think you're getting? Certification gives you that assurance. It probably gives you value into the future as well, because you've got a certified passive house with a plaque on the wall that in the future will add value, I suspect. Would you leave out the insulation? Well, I don't think you'd be listening to this if you thought you would, so I won't address that. But if you're going to insulate, then not to do the detailing on thermal bridging makes no sense at all, because you're just wasting your insulation. And again, the same with airtightness. If you're happy to have an inefficient building, to waste a lot of the effect of your insulation and to have drafts, then yes, don't do the airtightness, but it doesn't make a lot of sense. And once you start reducing your airtightness, it's then quite easy to get down to the sort of the stringent levels of passive house. And finally, mechanical ventilation. It's the thing that everybody talks about when they're in a passive house, the air quality, the comfort. Many people choose mechanical ventilation with heat recovery, even if they don't live in a particularly efficient building, because the air quality is so much better. And of course, it increases the efficiency of the building as well. So if you want to know more or to get some inspiration, the Passive House Trust website has an awful lot of free information available. You don't need to be a member to download that. Particularly, I'll highlight this button here. There's a projects database with a lot of the projects, if people bother to put the information up, on Passive House projects in the UK. So you can get some real inspiration about see what other people have done, really. And I think that's really helpful in the journey to considering whether you're going to go to a passive house for your own project. So finally, just thinking about what your next steps might be, if after today or after your learning more about passive house, you decide to go further with this. And I think the first thing is very much understanding what we're talking about, understanding what passive house is, get informed, start today with the information here today. So you're either a knowledgeable client, or if you're a professional, obviously, that even if you're not doing the technical side of it, that you really understand what this is about. So you can help your clients move down this road, perhaps with the help of a passive house consultant to do the technical stuff, but that you really understand what this is all about. Decide. So passive house principles isn't passive house. Is this aspirational? Does it make sense to you? If so, that's a decision you need to make. Start at the beginning. As I've said all along, you need to start at the very beginning of the project. Bolting passive house on later on can be very expensive, very difficult. It's possible, but it makes it much more difficult to do and to achieve what you want to achieve. Use people who know what they're doing. There's a good body of extremely well experienced and trained passive house professionals, and people who are trained and learning now. So use those professionals, make sure people know what they're doing if you want to go down this route, or if you are offering these services to your own clients, make sure you take up the training that's available so you really know what you're doing. And commit to passive house, not somewhere near. As I've said, this is very important. Otherwise, it's likely to be not somewhere near, but quite a far miss in reality if you don't follow all of these steps. And finally, well, yes, enjoy your fantastically comfortable, energy efficient, cheap to run new home. And just the last point, really, Passivhaus is the direction we're going in. The Committee on Climate Change, which advises the government on meeting its climate change targets, in this report that they published just over a year ago, said that all new build homes need to be highly energy efficient, typically 15 to 20 kilowatt hours per metre squared per annum by 2025. And that fundamentally is the definition of a passive house. So we are going in this direction. Exactly how long it take to get there, couldn't say. That's politics rather than science, but nevertheless, this is the direction that we have to go in. So that's my introduction. Just this picture is what an award-winning, quite a, well, I don't want to say quirky because I know the architect well, and but I like to finish with another passive house picture. This is in the Scottish Borders again, and won the award 2 years ago, Passive House Award 2 years ago, I think. So, questions, Harvey?
Great, thank you very much, Chris. Yes, we've got a few questions coming in. So let's have a look. So Jeff is asking about thermal bridging. So what work would need to be carried out to ensure there's no thermal bridging or loss in U value during construction, when you need to penetrate the insulation? And I think he's particularly thinking about ICF construction there, Chris.
Okay. I mean, fundamentally, if you're working with a passive house consultant or designer, this is what they'll be looking at. So, you know, if you've got handheld, but somebody knows what they're doing, then they'll do this. You see thermal bridges in your sleep, to be honest, when you do this stuff. The requirement is that either you've got continuous insulation, or where you haven't, you have to model the thermal bridge. So you have to put it into thermal modeling software to actually model it. And then you can see the effect, and that is plugged into your passive house planning package. Now, when you're designing, you try to design out anything that penetrates through the, basically through the insulation. What you look at is everything being in layers. So the structure of the building and the insulation not penetrating each other. And that they're being, so you take, a little bit like a human being. So our skin is on the outside. If you imagine our structure's on the inside with the bones, we've got the skin on the outside, we've got layers, and they don't penetrate, well, if they penetrate each other, it's quite unpleasant. And in many ways, you can take the same sort of metaphor, if you like, for buildings. If your structure, and occasionally structure has to go through, and there are expensive insulated solutions for steels to go through walls and things like that, but wherever possible, you want to design it out. And again, as you become more experienced with working with this kind of thinking, you find ways. I mean, balconies are a typical thing where balconies are often cantilevered coming out of the structure, but there are other ways of building balconies that are thermally separated. So you can use very expensive thermal breaks, or you can just design it out. So I think it's very much, you know, it's a general answer. Obviously, I can't cover the specifics, but I think, I hope that's somewhat helpful anyway.
Yeah, great. Well, I've only got a couple of minutes, Chris. I'd just like to get a couple more asked if we can. So Zoe's referring to Ben Adam Smith's case study yesterday, where early on in their project, they'd set a budget of, I think, around 400,000. And when the initial costs came back in, they were much higher than that. Some of them were twice as much. So Zoe's question is, how can you work with an architect to make sure that they're designing in line with your budget and your costs, so you're not going to be designed out in terms of affordability?
I think that's a very good question and not an easy one to answer, to be honest. You know, it is relatively quite notorious, not just in passive house projects, but generally, that architects will often tend to design you something more than you could really afford. I think I don't want to be offensive to architects. I've got many friends who are architects, but there is a tendency to go in that direction. What I would say is that if you can, working in partnership with a contractor rather than going out to competitive tender means that you could be doing an iterative process with the contractor at an early stage, working with the architect and your contractor. Sometimes we've worked on an open book way of working. You have a QS who gives you a sense of whether the contractor's being fair to you, but actually don't go out to competitive tender and work with the contractor from the beginning. That's probably a good way of trying to get a clear idea of the budget. I think in Ben's case, it went out. I have seen his presentation, and I think it went out to tender, and I think that was where the problem lay. But I may be wrong, because it's a while since I saw his presentation.
And we've got Alan Budden, who is an architect, actually talking later on at 1 o'clock today. So perhaps so you can ask him that question again at 1. Just very, very quickly, because we need to get finished. So I'm not sure the first name, but F. Sheridan has asked, they're building a Potton home, but they're only considering double glazing. Have we made a bad call in this regard?
So how can they?
So they're building with Potton.
Yeah.
Potton have got a show home here at the centre, but they're only considering installing double glazing. Have they made a bad call?
Well, I would say yes. I mean, actually, windows are one of my sort of specialist area in my own business, and I would always go for triple glazing now. Because of the comfort. Because basically, the inner surface of a triple glazed unit is a lot higher in the surface temperature than it is of a double glazed unit. It doesn't make a huge difference in terms of heat loss, but in terms of comfort, it makes a significant. So yes, for around 10-15% more on your budget for windows, and the windows are a very big budget element anyway. To getting the best out of that, yes, I would say it was a bad call, but it certainly is what I would choose.
Great. Okay, right. I'm afraid that's all the time we've got for questions. Remember to join us again at 3 o'clock, and we will try and get to some of the questions that we haven't been able to answer in this session. I'm going to wrap up really quickly. The next session, which starts at 11 o'clock, so we'll open it in a minute's time on the next Zoom link that you've all got, is with Anna Carson from Passivhaus Homes, and that is looking at REBA's 2030 climate challenge, and also features a really good Passivhaus case study, so that's definitely worth looking at. Chris, thank you very much for your time this morning. That was great. And we will see you again at 3 o'clock for the question time session. Have a good day, and we'll see you later. And we'll see you all on the next session in Zoom in a moment. Thanks very much for your time for this one. Thank you.
Thanks, Harvey.